Now let us discuss the next one. So this is something related to writing mechanism. So 10.51. So we have the problem number 10.51. This says we have this alcohol, basically tetrahydrofuryl alcohol. There is no need to remember the name. So you have this alcohol CH2OH. Now if this alcohol, question says if this alcohol is treated with H+, this rearranges to give this ether. You have to write down the mechanism. Now simple. Hint will be given to you. So first you do attack H+, make something good leaving group, lose H2O during expansion, then lose H+. You will get the desired product. Let us take 1 minute time. Okay, I think some of you might finish this one, so let us discuss. CH2OH. Here you have H+, so this goes here. So you will have this CH2 and then OH2 plus, and once OH2 plus is formed, this is a good leaving group. You can lose this one. Now I will have a primary carbocation CH2 plus. Now this carbocation is a 1 degree carbocation. This is a very less stable. Now I have two options. Either I can migrate this group or I can migrate this group. So let us migrate this first, and we will see why I am doing this. So if I migrate this group, what will happen? We will have 1, 2, 3, 4, 5, 6 membered ring. Are you getting? So you will have a 6 membered ring, and let us say here you have oxygen. So this is oxygen. So let us count if you are not able to understand. So this is 1, 2, 3, 4 and 5 and 6. So this is 1, 2, 3, 4, 5, 6. Now see, basically on carbon number 5, if you remove this group on carbon number 5, you will have a positive charge. Are you getting or not? So if you remove this one, you will have a positive charge on carbon number 5. So this is 5 is this. I have simply missed. This is 4, and then I have to write 5 this one, because 4 and this carbon is connected to this carbon, so this is 5 and this is 6. So 1, 2, 3, 4, 1, 2, 3, 4, and this carbon is connected to this carbon, so 5 is this, and then this is 6. So now you see, if you do this, carbon number 6 will have a positive charge. So if this goes here, carbon number 6 will have a positive charge. Are you getting? And now this positive charge is basically resonance stabilized. So I can write one resonating structure for this, something like this. So this positive charge is resonance stabilized by lone pair of oxygen, and that's make this carbocation stable. So you can have a stable carbocation, because of the resonance through oxygen. So this is a stable carbocation. Now the next step is easy. You can lose H plus from here. So if you have copied this one, then I can go forward. Let us keep copying fast. So now next step, I can lose H plus from here. So I have a positive charge, here I have H plus. So if I lose H plus from here, I will get the desired product. So from here, I will get the desired product. Are you getting? Now one important point also that we have addressed earlier. At this point I have two choices. Either I can migrate this group or I could have migrated this group. Let us see what happens if you migrate this group. CH2 plus. Now if you migrate this group, again you will get 6-membered ring. Now this oxygen, this has gone here. So which carbon will have a positive charge? This carbon will have a positive charge. So this is my O, and O is connected to CH2. So O is connected to CH2. And our next carbon, this carbon will have a positive charge. So this carbon will have a positive charge. Are you getting? In this case, there is no resonance stabilization. Oxygen will not in resonance. So no resonance stabilization. So this molecule is not stable. And that's why this alkyl shift will not take place. Because of if I shift this one, the positive charge coming is here. You can see yourself. This oxygen is connected to this CH2. So this oxygen is connected to this CH2. Now next carbon will have a positive charge because I have broken this bond. So this bond has broken and this bond is connected to this. So this carbon will basically have positive charge. So this carbon has positive charge. So this positive charge is not resonance with oxygen lone pair. That's why this is not very stable. So not in resonance with oxygen. Not in resonance with oxygen. Are you getting? And that's why less stable. Are you getting or not? So if this is less stable, this I is not formed basically. Are you getting? So that's why I have to migrate the alkyl group from other side. This is the important point in this question. I think all of you have copied this one. If you are missing something, let us copy fast. Okay, let us discuss the next problem.